Alrighty, in this next problem, 6.5, we are asked to determine which of these two measurements is greater, 75 grams or 5 ounces. Now, as I'm looking at this problem, I'm not happy with the fact that 75 grams is really a measurement of mass, 5 ounces is really a measurement of weight, but here on Earth, mass and weight are basically interchangeable. So I'm not going to concern myself with that too much. But we need a strategy here. How in the world do we tell which one of these is greater? Well, you can't compare apples and oranges, is basically what this problem comes down to. So we need to convert 75 grams into ounces in order to compare it directly with the 5 ounces. Or we could do the opposite. We can convert 5 ounces into grams. It doesn't matter which way you go. You're going to come to the same exact conclusion if you do it right. So I'm going to go ahead and convert ounces into grams. So 5 ounces is equal to how many grams is my question. So I'm going to set up my train tracks. Looks like this train track got hit by an earthquake. Now I'm going to have 5 ounces up here and then grams over here. So I need some conversion factor that relates ounces and grams. So let me go to my best friend. Alright, ounces and grams. Oh, right here. 1 ounce. 1 ounce is equal to 28.35 grams. Sorry, that's off the screen. That's the conversion factor that we're going to use. I need ounces on bottom in order to cancel these guys out. Too many pens. Trying to juggle too many pens. Ounce. 28.35 grams is going to be on top. So what this is really telling us to do is take 5, multiply by 28.35 to get the answer. 5 times 28.35, 141.75. I'm just going to round that to 142. 142 grams. So let's go back to the drawing board. What does this mean in the context of the problem? Well, 5 ounces is equal to 142 grams, and 142 grams is greater than 75 grams. So 5 ounces is bigger than 75 grams. Okay? 5 ounces is the bigger quantity of these two. Alright, let's take a look at 6.6 now. Uh, 6.6. A gerbil eats about 1/4 of an ounce of food per day. About how many pounds of food can the gerbil eat in a year? Alright. Let's try to figure this one out. I'm trying to figure out how to show everything on one screen. 1/4 of an ounce of food per day. Now, so that's basically what we start out with. 1/4 of an ounce per day is equal to pounds per year. How many pounds per year is this quantity equal to? This right here is basically our problem. Now, let's see what all we have here. I think a couple of you were confused by the whole fraction thing going on right here. Please don't be. This should not be scary. 1/4. You could just convert that into a decimal in your head, I hope. Don't be afraid of that fraction. We just threw that fraction in there just to keep you on your toes, sort of thing. So again, this is the way that your train track should always look. I know I have 1/4 of an ounce up here. I'm just going to write that as a decimal. 0.25 ounces per day. And I'm converting that into pounds per year. Alright. We have two different problems going on here. We need to convert ounces into pounds. That's our first problem. So let's use our best friend, find a relationship between ounces and pounds. Let's see, ounces and pounds, ounces and pounds. Oh, right here. 1 pound is equal to 16 ounces. Okay, so I'm going to write that out here. 1 pound is equal to 16 ounces. I have ounces, so I need to cancel ounces out. So 16 ounces is on bottom. Trying to juggle too many pens again. Ounces on bottom, ounces on top, cancel. And 1 pound is going to be on top. So I have pounds on top. I want pounds on top. Voila. Good. Now, let's convert days into years. Last time I checked, there were 365 days in 1 year. Well, I have days on bottom, so I need to have days on top in order to cancel it out. Days, days. 1 year is going to go on bottom. So I have years on bottom. I want years on bottom. I'm done. Alright? So I had actually laid down way too many train tracks. Far more than I needed. And that's okay. Just don't use those. That's fine. So what this is really telling us to do is take 0.25, multiply by 1, multiply by 365. All of that divide by 1 day. 1 times 16 times 1. Alright? Again, the ones don't matter. 0.25 times 365 divide by 16. So let's use our calculator to do that. 0.25 times 365 divide by 16. 5.7. Alright, 5.7. 5.7 pounds per year is our answer right here. So I'm going to transfer that over. 5.7 pounds per year. Fantastic. Now, last problem. Probably the most difficult one, just because of the number of steps that it involves. A pitcher throws a baseball at 90 miles per hour. How many seconds does it take to travel the whoa, come on, paper. How many seconds does it take to travel the 60 feet between the pitcher's mound and the home plate? This is kind of an interesting problem. Have you ever wondered how long it actually takes? How much time does a batter have to react to a ball being thrown in his direction? How long does he have to start swinging and all of that? Well, let's find out how much time a batter has before the ball passes the plate. So let's take a look at some of the numbers we have. We have 90 miles per hour. 90 miles per hour. This is a speed or a rate, okay? In this physics class that you're probably in with me, I want you to start using the word speed instead of rate, because rate can mean any sort of ratio, and usually involving time. Speed, in particular, is a rate involving distance per time. Anyway, so speed, and then we have another number in here, 60 feet. What is 60 feet? Well, this is a distance. Now, first question, always, when you are dealing with a word problem like this, is ask yourself, what are they asking me for? Well, they're asking us how many seconds. So they're asking us about time. They're asking us to find time. Alright? Well, that's the first step taken care of, easily enough. We figured out what they're asking us for. Now, the second step is usually, are there any formulas that can help me? Any equations that can help me? So in the case of conversion factor problems, you ask yourself, are there any conversion factors that can help me? In this case, this problem is a little bit more complex. It's going to involve conversion factors, but it's also going to involve some formulas. And the formula I want you to think of is, you probably learned it in middle school, it looked like this. Distance equals rate times time. Alright? in physics, the same exact formula is going to look like this. Speed is equal to distance divided by time. All right, they're the same exact thing. All right, just divide both sides by t here and call rate by another name. All right, no big deal. These are the same exact thing. So we're going to use this formula because this formula relates speed, distance, and time. But let's look at the problem though. What is the issue here? Well, our speed is given in miles per hour. Our distance is given in feet, and our time needs to be in seconds. Right? So our speed is not compatible with our distance nor our time. So the easiest thing to do, basically, before we can use this formula here, is to convert our speed into feet per second. Okay? That's where the conversion factor aspect of this problem comes from. So we're going to convert 90 miles per hour into feet per second. So, train tracks. Train tracks. I hope that you're writing this down with me. You're not learning anything if you're just listening. You might be learning a little bit, but not as much as you could be if you were actually taking the time to write down with me. So, what goes up here? Well, 90. Remember, mph, thought bubble, that means miles per hour. So 90 miles, and then hour on down here, 1 hour. And then we want to convert to feet per second. Pardon me, I still have a cold. Alright, we want to convert from miles to feet, first of all. Alright, that involves our distance. How do we do that? Well, I hope you guys remember this conversion factor. I'm not going to look it up on my best friend. 5,280 feet is equal to 1 mile. Alright, sound familiar? That number should be a number that you've memorized by now. So, I have miles on top, I want miles on bottom. 1 mile on top is going to be 5,280 feet. So, miles cancel out. Feet on top. Feet also on top. Alright, I'm good. Feet have successfully, I don't know what I'm saying. Miles have been successfully converted into feet. Now let's convert hours into seconds. Well, I know that 60 seconds is equal to a minute, and 60 minutes is equal to 1 hour. So let's use those. I have hours on top, so I need hours on top to cancel it out. Hours, hours. 60 minutes is going to go down here. Minutes, seconds, so I need to have minutes on top in order to cancel it out with that. 60 seconds is going to go down here, and then that's it. I have seconds on bottom, and I want seconds on bottom, so I have exactly what I want. This is telling me to take 90, multiply by 5,280, multiply by 1, all divided by 1 times 60 times 60. Alright, let's see what that's equal to. Now you could do this all in one step on your calculator. Let me show you how to do it all in one step, because it's very important that you know how to do this. So you have to put parentheses 90 times 5,280, alright? Then I'm going to push the right button. I'm going to hit the division, and then parentheses again, 60 times 60. Okay, so this would be an acceptable way to calculate this quantity down here. You just have to make sure to put the whole numerator and the whole denominator in parentheses. This is equal to 132. Alright, so 132. Remember, this had units of feet per second. 132 feet per second. Alright, so let's write down what we have again. We know that our speed is 132 feet per second. The baseball travels 60 feet. and our time needs to be in seconds. Alright, now it's just time to use that formula. Right here. We know what the speed is, we know what the distance is, we need to know what the time is. Okay, so let me take this formula. Speed is equal to distance over time. And then, or actually let me use the one that you're probably familiar with. We're going to use this particular form more often in physics class, but this is the formula that you probably have memorized from middle school. We know this, we know this, we want this. So in order to isolate the t, we need to divide both sides by the rate, by the speed. Alright, so distance divided by the speed is equal to time. Alright, this is telling us to take the distance, which is 60, divide by the rate, which is 132, and then this is going to be equal to 5 divided by 11. Shoot. I want that as a decimal, so I'm going to hit Control, Enter. There we go. It worked this time. 0.45. Okay? 0.454545. I'm just going to round that. 0.45. So, this says that the time it takes for the baseball to travel from the pitcher's mound to home plate is 0.45 seconds. Less than half a second. So this is a pretty fast ball. You know, I couldn't throw it that fast. But in the major leagues, it takes less than half a second for the baseball to travel from the pitcher's mound to home plate. That is not a whole lot of time to react, much less get your arms swinging. Alright, that is it for objective number 6, conversion factors. I hope this video was helpful for relearning this skill, and I hope that you are ready to now retake this objective. Come see me in advisory.